right? So can I
Okay.
ask you next question? If I change anything into a file's hard link, will it get reflected into the original file?
Yes, sir.
Okay. And what about symbolic link?
So it will get updated, right?
Yeah, in case of hard link, it will get updated. In case of soft link, it will also get updated. So why do you need to have a soft link and a hard link? Any guess is fine. Okay, I am
So
pretty sure. uh, Go ahead.
in case we need to have a use a path for something.
Hmm. So
Sir,
yeah, Krishna, go.
uh, in symbolic link, only one file will be there, and maybe others pointed to it. And in hard links, every time each copy will be made, something like that.
Hmm. So like any other guess? Like I see only two of you are, three of you are participating. What about others? Sanket, Vaishnavi, Akhil, nothing? No guess? Okay. So what essentially the difference between a hard link and a soft link is that a hard link is identified by inode number, right? An inode number is where the file details are usually stored, right? If a file is simply linking to an inode number, it is essentially, it's like a postcard, okay? It's like an address. Okay. For the same address, you have two different postcards going in. That is all a hard link is. While what a soft link is that it stores the information where the original file is located. So if you make changes or to the soft link, right? Say you go into your soft link, it will always point it to directly to your, the original file, right? But your if you see there are few soft links, right? I see the second line itself. You see the size of this file, right? How much is it? Just 34 KB, right?
Yes,
Another
sir.
one is there. It is just 31 KB, right? Another one is there. This xzcat, right? It is just 2 KB, 2 bytes, right? 2 6. So essentially, they are only storing the path for this. So you see the like xzcat, which is I think 1 2 3 4 5 6, right? Six command, right? Look at sixth and seventh command, right? So sixth command is what your xz, right? And for xz, you have a symbolic link in xzcat, okay? While original file is 80 KB, right? The link itself is only 2 bytes. So it is only storing the path where the xz is actually located. So in this particular case, it is not storing. Is it storing a relative path or is it storing a what do you call a full path in the link?
Relative path.
Right? It is only storing the relative path because both of the files are in the same directory. Xcat can point it to the xz which resides in the same directory. Meanwhile, you see the second command, right, which is x window dash manager, right? It is pointing to a file which is present in the etc directory, right? So this is your full path, and where and down below you see these are your mm, relative paths. Okay. The other important aspect is that if you like, I don't see an hard link here right now. Can you just get an output first 10 lines, 10 or 20 lines of this? Just pipe it, Aditya, and get
Uh,
only the first 10 lines
First 10 lines as in
or 20 lines of this output. LS.
okay, okay. I'll use the
Yeah.
more command then.
Maybe head command.
Head command has been taught, right, by sir?
Yes,
Yes,
sir.
sir.
Yeah. No, you have to put a pipe, a vertical line between before head. Okay, this is something you will learn later. Okay. So right
Yes, sir.
now he hasn't given any option to head. That is why it is showing you only the 10 lines. First 10 lines which is present in the output of the LSLI command. So you can see that are there any hard links? Let me see here. Are there any hard links? I don't see any. Can you
No,
do
sir.
head space hyphen 20? Are there any hard links? No, it's not there.
No, sir.
Okay. Where else can we find hard links? Usually, bin should have. Let me do one thing. Okay, I'll share my screen. Mm, yeah. Uh, is everyone able to see my screen?
Yes, sir.
Yes, sir.
Okay. So these are the file which resides in my bin directory. Okay. So if you go, so I have run what ls hyphen lih. So based on the basic knowledge, right? The way we execute command is that a command, then space, then whatever flags you want to give, right? You can combine them together also. So L is a separate flag, I is a separate flag, H is a separate flag. But if you want to combine them, you can combine them like so. Okay. If suppose a command has to be executed on a file, you have to put command and then the file name, right? Okay, that's how we usually go. The other thing in this output you need to notice is that these are your inode numbers, permission strings, number of links which you have. Then what is this column? Anyone?
Owner.
Owner,
Owner.
sir.
Owner name.
This is owner. What about this one?
Group.
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 Right? And this is your size. This is your date of last modified or creation.
Creation.
Creation, right? Or modified.
Last modify.
Last
Modified.
modified.
Last modified.
Okay. So if I go by this particular column, right, I see that this particular file bunzip has 3 hard links, right? And now I would like to see the same, like, so number 22 I should see in this list, right? Because these are the hard links. So essentially any file which is a hard link of bunzip2 should have the same inode number. If I go down, I see one hard link here, which is your bzcat. Okay, it also shows that it has 3 and it has the same size as bunzip2, right? Then we go again and scroll, we see there is another one here. Okay, this is bzip2 and it also has 3 links and is exactly the same size as before. Okay, there should be one more 22, right? Or that should be enough for 3 links. Hmm? How many files there should be when it says that there are 3 links? Hello?
Three only.
3 only,
Three.
right? So this is 1, this is 2, and this is the third one, right? All 3 of them has the same inode number. So essentially the content of the file, right, on the hard disk, it is at the same location. Okay, it's just that it has different name. Maybe bunzip2 is another name, your bzip2 is another name, and then maybe we'll have another 22. Where it is, yeah, bzcat, this is another name. Okay, but all of these 3 goes to the same address. It's as if I'm in a house, I am posting, like I am receiving a letter by my name, my father's name, and my mother's name. Although the address remains the same, right? So the content the place where it remains the same, but it may be addressed by 3 different names. That is what your hard link is. So any changes you make in any one of the hard link will be reflected in the other two, right? Because it is going to the same address, right?
Yes, sir.
But in case of say what do you call, and you can also move this file, right? Move this file anywhere. Like in this particular scenario, I see that BTRF SCK is a symbolic link, right? Because I can clearly see there is only one link, and it is pointing to BTRFS, which is in the same directory, right? But this is a symbolic link, okay? But symbolic link has 5 bytes of size, and where is your BTRFS, right? It is around 700K, right? So definitely the file, like these two are independent file, but BTRFSCK, right? It points to this particular file. So it stores the information regarding this file and where to find it. Meanwhile, the hard links are just storing uh, the same content under a different name. Okay, that is the difference between the two. So if I want to do an analogy between a Windows system and a Linux system, I would say the Linux system, in the Windows system, whatever the concept or shortcut you have, right? That is what a soft link is. Okay. If you move this, say in this particular scenario, right? We know that this is a soft link to BT RFS, right? If I move this files in some other directory, this link will not work. Okay, because I have saved it a relative address here, not a full address. If I have to save a full address, what will be its full address? Can anyone tell me? So
Slash bin slash BRTFS.
right, that's what it should be there, present there, which is not. Okay, so that is the difference, and that is a very important aspect that you should know. First, you need to know that there are fixed number of uh, inodes which are created at the beginning of the whenever you initiate your Linux operating system. Okay, now there are different, like you have you heard about this FAT32, FAT, or NTFS partition file system,
Yes, sir.
right? Right, those are pertaining to Windows. When it comes to Linux, it is ext, ext3, ext4, right? And then there are also which are modern file system, which allows you to do much more than what your traditional file system were capable of. Like in case of this inode issue, right, where the fixed number of inode are being created, and that will created at the beginning of the system. So it doesn't allow the system to be expanded or contracted as and when required. So eventually few people went ahead and developed file system which will accommodate that. As and when it is required, it will create new inode, right? Those are advanced level file management system. But the basic file management system with which the Linux was developed, it had fixed number of inodes when the system was first installed into the system. And this is very important when you're saving so many, like, each of the file will eat up at least one what do you call, your inode number. And say if you have millions or billions of such small files, although your space, like your file, your memory can memory, say for example I have a 1 TB hard drive. Okay, and in the start of the system I created almost around a million inode numbers. Say I got another million files to store on this hard drive, but together their size is less than 1 TB. Maybe it is only say 100 GB of data, right? You still have 900 GB of data which is left, but you cannot use it because you have used all of the inodes which were present at the beginning of the uh, like whatever it was created when the system was first booted. So this is very important because when it comes to logging, right? If you are on a server side and you're generating logs, a lot of small logs, or you're downloading a lot of temporary files in your temporary directory, right? It may fill up this inode so quickly that even if you have space, your system will slow down. there will be a lot of issues which is pertaining to memory, and there will be a lot of issues where you, even when you have such a huge space available, the system will not simply copy your files, and it will give you a memory error. So in such a scenario, you must remember that, must, there could be an issue which is pertaining to the inodes.